Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field.
Hey, have you ever been faced with the challenge of sourcing, installing, and programming a used control module in a vehicle? I know a lot of us have. It seems to be happening more and more often today with the volume of control modules on vehicles, the cost of some new ones, or even the availability of new control modules. In some cases, used may be the only option. So what do you do here? I strongly recommend checking out SJ Auto Solutions and Tommy Oliva. Tommy offers a cloning service for used control modules to make these things plug and play for the vehicle that you're working on. In a lot of cases, he is also able to source the control modules if you're unable to locate one for the vehicle that you're working on. But once you get connected with Tommy, he's going to offer fantastic support from start to finish to make sure that that control module is going to work in your application. He's also got tech support that he offers through his website, along with some free resources there as well on information about used control module programming. So make sure to check out SJ Auto Solutions. I can't recommend that enough. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I will be your host once again for this week's episode. You got just me this week. Tommy is back. He made it back from his Australia and New Zealand trip. We'll get him back on the show here in the next few weeks. We got some interviews lined up, but for this week, I'm going to share some tips and tricks and real life experience with single module, no communication, right? So you have one control module. It is disabled in a way where you cannot talk to it. And most likely there is a function of that module that is not working, right? If you're looking at the vehicle, there's probably something wrong with it, but this module runs a particular function, right? Headlamp control module, transmission control module, fuel pump control module, whatever it is. And you've connected to that vehicle and you can't talk to it with a scan tool. It is in no comm. So where do we go with this? How do we condemn a control module or say that it is something else? This is part of a class that I've taught a couple different places, which is how to condemn a control module. I got a whole 4-hour class on it, but these will be just some tips and tricks and things that I've run into recently and a few things that I want to point out. So first things first, when you connect up to the vehicle and you're attempting to talk to said control module, again, there's probably something wrong with the vehicle. Be real careful. If there's no problem and you just happen to see that there's not communication with a module, there might be some reasons for that. Maybe that module's not even equipped on the vehicle, right? That could be a scenario. And then tied in with that is aftermarket tooling could mislead you. And it could mislead you in a couple different ways, right? It could show you a module on the topology or on the list of modules that it can talk to and make you think that it's equipped on the vehicle when really it's not equipped at all. That vehicle never had that module, but it shows up and it shows no comm when you attempt to reach out on it, or it shows up on the topology screen. There's even situations where there will be multiple modules that have similar functions, and depending on the year or depending on the model, it may have used one or the other. And so you're trying to talk to the immobilizer module, but really it's the smart key module because that one's a push button. One brief example of this is Hondas. If you've ever connected to a Honda with an aftermarket tool, it gives you every module Honda ever created on the list. And the scans take a little bit longer because of that, because it's looking through every single possible Honda module. And most of them on most cars are not equipped. So that's something to be aware of. Now, let's say that module is equipped on the vehicle. Again, we're probably going after an issue with this particular module. But let's say this module is equipped. You verified that. but your tool is still not communicating with it, it could still be an aftermarket scan tool issue. That this tool, for whatever reason, the software that was built into it, the interface, there's an error, there's something missing, that it's going to show you a no-com, but there really is no communication issue, right? There still could be an issue with the module in question. Maybe it has a code in there referencing what's wrong, but it's showing up as a no-com on the scan tool. And so this can happen a lot of the time with aftermarket tools. One example of this, well, I'll give you a couple examples, so I'm not just picking on one tool, because it happens with just about every aftermarket scan tool, has various holes. Topdon has issues with e-chassis BMW DMEs, where it will show it's no-com, but it's really not a problem. Autel, I've had this problem with early 2000s GM trucks, where it will not communicate properly with side detection modules. And I'm sure there's examples with Snap-on. I don't have a Snap-on, so I can't tell you which one, but we've gotten calls in, to do certain scan tool functions that shop Snap-ons won't. So you're going to run into this, okay? So how do we identify that that is the case, right? How do we know that it's a scan tool problem with the communication of the module and not an actual communication with said module? Well, the very first thing you can look at, and you should be doing that full vehicle scan where you connect to it, pulling codes from all modules, is if that module is really offline, it's not talking to anybody else, and this is on a modern vehicle with a CAN network or some sort of multi-module network, there should be other modules reporting communication failures with that module. It may not be everybody, okay? There are certain modules, like a side detection module, for instance, or a headlamp control module, might not care that the transmission control module is offline. Maybe it does, but I'm just giving that as a reference, is that there are some modules on the car that don't get messages from other modules. And so not everybody will code, but somebody cares that that module is offline. The whole reason that module is on a network is to communicate with other modules. So somebody, at least one other module, should be upset and coding that that module is not receiving what it needs from said module. So if you have no other communication codes in any other modules, and you can't communicate with a module, you should be thinking like, hey, this could very well be a scan tool issue. What can you do in that case to verify? I would go to said module if it's accessible, and I would unplug it, and then I would see what happens with the rest of the car. If everybody else at that point sets communication codes, or you could pull a fuse for it if it's hard to get to, but then if everybody else sets communication codes saying, hey, I can't talk to this module, and those codes weren't there before, it's very likely a scan tool issue. Unfortunately, just in all transparency, I can say this is not 100% accurate. We recently had a Porsche Cayenne where the TCM was exactly that. It wouldn't communicate with any tool I had, and I don't have the Porsche factory tool, unfortunately. But I did 4 different scan tools. Nobody talked to the TCM. This car wouldn't shift. It was in a limp mode. I even tried Otis as a tour rig because the Porsche Cayenne is just a tour rig in disguise. And I couldn't even talk to it that way. We did the whole powers, grounds, network, all that stuff. When you would unplug the TCM, everybody was then upset. Like, hey, I can't talk to the TCM, but you plug it in, no communication codes, but we couldn't talk to it with a scan tool. And that ended up being a TCM. So that's kind of going against what I'm saying, but I have to say it because that's real life. Like, we can talk about this stuff, and I can give you some tips, and that's what I'm doing, and this is going to work 99% of the time. But do keep in mind, none of this is guaranteed all the time. You're going to run into some exceptions. And that's why we'll go through the rest of this too, is let's look at everything else surrounding the module and involving with talking to a control module, and then we can hopefully make an informed decision. We got to a point where we kind of had to guess on that Porsche, and we had him get a used module. I was like, just, hey, get a used one. We'll at the very least see if we can communicate with it. But I got to the point where I was out of options to try, besides getting the Porsche factory tool, which I just haven't committed to yet. That did end up being a TCM on that. But on most vehicles, if the module's plugged in and no one else is upset, no one's throwing any communication codes, and then you unplug it, and then modules set communication codes, you should really consider your scan tool. Now, The other thing there that we want to consider is what network or how does the scan tool I'm using communicate with the module in question, right? So am I hardwired to the DLC? Is the same network that I communicate with that module on connected right to the DLC, or is there a gateway? Is it possible there's an issue or coding with the gateway? Maybe the gateway was replaced, and so data isn't transferring across the gateway to my scan tool. That's a possibility, and I considered that with this Porsche. But the other thing around which network is you could have a module that is connected to multiple networks. And this gets tricky as well, because then the question is, which network does the scan tool communicate with the module on, right? In some cases, you might actually have just a dedicated diagnostic line to a particular module, and then it's on a CAN network with a bunch of other modules. Or you could have multiple CAN networks to a single module. And that is a tough question to answer at times, and you may just have to get into the actual network testing and see what's going on there. Maybe you can find in-service information which network is the one that the scan tool actually communicates with. Maybe some topology could help, but that is where it gets tricky. Now, I am going to skip some major network failure causes because that can definitely happen and cause communication issues with a module. I'm generally going to skip past that here because that's more network diagnostics and not so much focusing on why a single module doesn't communicate. But again, like we talked about, scan tools, and your best bet's to use the factory tool if you have it. I realize not everybody does, especially on new vehicles, right? If we're working on a 24 or 25, aftermarket tools are going to have holes. That's going to be the case. You're going to run into things, and even if you can interact with the module, you may not have proper functions. We just had a 21 GMC Yukon. I don't have an aftermarket tool that could properly interact with that air suspension module. One of them wouldn't communicate at all. One of them did, but couldn't run the functions. I had to use GDS2, the factory tool. And so that's your best bet, right? If all this stuff that I've been talking about so far, you can eliminate the question marks by using the factory tool and the factory interface. And that's not always doable, although with the R2R, the right to repair, you can have a version of the factory tooling for most manufacturers. You might be using a JBox, which does add a question mark in there, but it's a lot closer than some Chinese scan tool, right? You can use that R2R software as another attempt with a short-term subscription to see, okay, can I interact with this module the way I want to, right? So beyond this scan tool thing, we're considering how does the network connection happen between the module and the scan tool when it's plugged into the DLC, right? Am I hardwired? Is there a gateway? Is there multiple modules? How do I look at it that way? And at that point, once we've eliminated those as possibilities, which again, aren't always the easiest thing to do, but if we can get past that and go to the module, and maybe that's our only choice is if we've got to go to the module, what sort of things are we looking at then? Now, this is pretty straightforward, obvious. I won't spend a whole lot of time on it, but I do want to make some points. You have power, ground, communication, ignition, wake up. Those are the four things that you're going to need for a module to communicate. And then there are some, I guess, other things that we'll mention, we'll bring up. But when we go to a module for testing, that's generally the things that we're going to be looking at if we can't talk to that module. Do we have power? Do we have ground? Do we have some sort of ignition wake up? And then are the communication lines or line connected to the module, right? If you're going to be testing at the module, remember pin fitment. You can back probe, but pin fitment's a good thing to test and a tough thing to pinpoint, if you will, if it's intermittent. We just had a Infinity QX at our shop for a couple weeks with an intermittent pin fitment issue at the ECM, and that is a really tough thing because you can't just wiggle the wires and get it to happen. It was really temperature related, and we finally got it, but the pin drag testing was huge in order to identify that. That was the final nail in the coffin, like, okay, we got this. So when you're testing, make sure that we've got proper pin tension. But then you can use a diagram or potentially a connector view pinout in order to find your powers and your grounds. And I think I've mentioned this on other podcasts or classes. If you're looking for where are the powers, where are the grounds, where are the ignition wake-ups for a particular module, it really does vary depending on the manufacturer that you're looking at. Like GM does an awesome job of just giving you a diagram of all the powers, grounds, communications for said module. It's going to exclude all the other wires, but all the real critical ones are right there. Some manufacturers, not so great at that. They're just going to give you everything and you've got to sort through it, several pages to find what you're looking for. Maybe you're using a redrawn, be careful with accuracy, but at least they're standardized. You have your eyes trained to look at the top of the page for the power distribution, relays and fuses that feed into that module. You can look for the ground symbols, that are generally going to be close to the module on the diagram. Okay, those are the grounds we're looking for. And then there'll be, two wires that are cut off and say they go to the computer data lines diagram. And okay, these are communication. You can sort through it that way. Again, connector view is another one that you can look at, and it's a longer list, but then it actually gives you the place on the connector that you need to test. One thing to keep in mind when you're looking at diagrams is, and I'm sure most of you are aware of this, but if you're not, if you look at the module that you want to find all the powers and grounds, and you do want to find all of the powers and grounds, that's a really important piece I'll come back to. If the square or the rectangle that makes up the module in the diagram is solid, that means that's all the wires, all the circuits that connect to that module are on that diagram. If it is a dotted line that it makes the outline of the module, then that means there are more circuits that are not included on that diagram. Okay, so that's an important thing to know, because if you want to find all of the powers and all of the grounds, you want to know, does the diagram I'm looking at include all of them, or do I need to go look at other diagrams? Because you most likely, with a lot of control modules, especially something like an engine control module, will have multiple grounds, multiple powers. Maybe you have powers, switched powers, serial data wake up, or some other type of ignition wake up that's maybe not quite as obvious, right? Again, like I mentioned, you could look at a redrawn diagram and you can find the power sources. They're always going to be up near at the top of the diagram somewhere. And you can find the power in, and a lot of times they're labeled B plus or switched ignition, ignition on, something like that. And you're like, okay, power. But serial data wake up can be a little trickier to identify, and I've seen this burn text before. This is a ignition on, if you will, but specifically for the module to talk on the network, right? So we're going back to, hey, we don't have a module that's talking. Yeah, we need power. Yeah, we need ground. Yeah, we need to find all of them. But the serial data wake up, and this is true of GM vehicles and probably others as well, that can come from another module. Okay, so if you're training your eyes to look for powers kind of at the top of the page or things that are labeled B+, it's not going to be quite as obvious because it's going to come from the BCM in these GM examples. So it's going to come from another module. Now it is 12 volts on those serial data wake up circuits on GMs. It'll actually light a test light, but it comes from another module in order to wake that module up so that it will talk on the bus. If you don't have that, you can have all the other powers and grounds, it will not talk on the bus. And you might think, oh, okay, the module's bad, when it's just a connector up on the left front strut tower has a corroded wire. I'm giving a real life example there of like a Chevy Tahoe. But this show is brought to you by Auto Rescue Tools and Isaac Rodell. If you've been looking for a programming laptop, but you're not sure which one to buy or how to set it up, especially if you want to program multiple brands. You've got some domestic vehicles, you've got European vehicles. Can the same software go on the same laptop? What size hard drive do I need? All those questions. Isaac's your guy. He can custom set up programming laptops that are ready to tackle any make or model I've got one of these laptops myself, and I can say that it is outstanding, and it really streamlines the process by having everything you need in one device. So if you're looking for something like that, I highly recommend checking out autorescuetools.com. You'll also find scan tools, diagnostic equipment, key cutting equipment, and much more. Check out the link in the show notes. I highly recommend it. We got to look over the diagram and make sure that we've got everything that module needs to turn on and wake up, right? If we've only got some of the powers or some of the grounds, that's where we can get into a no comm situation. All right, so powers and grounds, when are those switched ignition signals supposed to be there? There are examples where that happens over the bus too, and that can make stuff tricky because you can't necessarily measure that with like a test light or a voltmeter or a scope. You're going to have to use a scan tool. You're going to have to figure out who is the power mode master. How does that wake up signal get transferred over the network? If that's the case, there'll probably be some other modules that are offline too. Again, that's maybe a little bit outside of the scope of this talk, but just be aware that, hey, sometimes modules do need a wake up signal from another module over the network. And I will even show you a way you could potentially identify this depending on the module in the car, right? And I did mention that we want to identify that the network is connected to said module, and that will depend on the type of network that you're working on. A lot of modules nowadays are CAN, but there's a bunch of different options, obviously. One of the things I'll do with CAN, this is just a real quick check, is I will be testing at the module, right? We've got power, we've got ground. I'll go to my CAN lines and I'll do one of a couple things. And you might consider one of these risky, so there's other options. There's other ways to do this. You can use a scope, you can look at the waveforms, and I'm not saying don't do that, but I like to test as quick as possible, get my answers as efficiently as I can. So if I get to CAN lines, just regular, 2.5 to 1.5, 2.5 to 3.5, I can look at it with a scope, cool, but I don't know for sure maybe if that network is complete or not, right? I could be seeing traffic, but it's from another module that's on the leg, but it's broken between those two modules and the rest of the network. It's possible, right? The waveform might change, but here's what I do. I will jump the two CAN lines together with just a jumper wire between the two. And then I will try to scan the rest of the vehicle. And usually the dash starts dinging and you hear signals from the rest of the car like, yep, I just shorted the entire CAN network, right? If I do that and then I have my scan tool and I try to talk to, I do like a full rescan and that whole network is down now. Okay, well, I know those two wires up to that point to the module in question are connected to the whole rest of the network. Has to be. And then you can take that off, and honestly, if you do that, you will be fine on a CAN network if you just jump it together. It will come back. It won't permanently damage anything. I'm sure I say that'll happen, and somebody will send me a bill on some Maserati or something stupid that damages the CAN network. But I have yet to see jumping two CAN wires together cause any permanent damage. You remove the jumper and then it comes back. Anyways, it's a quick check that I make, and it just tells me that up until that point of that module, the whole rest of the network is connected. If I'm doing it with like a single wire CAN, I will take a grounded test light that I was using to check for power, and I will put that on that single wire, GM LAN or LIN bus or whatever. And if that takes down the network, okay, I know that the wire is connected to the rest of it. Again, it's a little down and dirty, maybe not ideal, but it's effective and it works. And I may even, confirm with the scope, but it's a quick check to tell me where I'm at. All right. Before we leave the topic of powers into a module, I guess we did already a little bit. Let me come back to this because this is actually the thing that spurred the thought to make this episode and that I wanted to bring up. Now, I'm sure there are examples of this used in other modules, but the primary one that we see this used in is engine control modules, powertrain control modules, DMEs, right? The module that controls the engine, where there is a relay, a PCM power relay, a DME power relay. They have various names, but what they do is they provide power on either one or multiple circuits to the engine control module, right? So this relay provides power once activated to the engine control module. But here's the thing, and there's plenty of relays that supply power to modules. That's not exactly where I'm going. These relays are also controlled by the engine control module. So I'm sure most of you have seen this. This is used across many different brands where the PCM power relay, I'm just going to reference it as that. I know there's different names, supplies power to the module, but it's also controlled by the module. Okay, so let me give you an example. I had a Hyundai Santa Fe, I think it was a 14 recently. We had no comm with the engine control module. Now, when I was going through my tests, and I was back probing on this one, I had no power on the circuit that was provided by this relay that the engine control module turns on. So my question is, well, if this module's dead, of course that relay won't be on because it's not going to be controlling it. But is it possible to have something wrong with that relay or the circuits connected to it where it's not being activated or the power's not reaching the PCM on that circuit? Will that prevent that module from communicating? And here's the deal. This is the important part. This is where I'm going with this, is it depends. And I'm sure many of you have run into scenarios in both situations where this PCM power relay is disabled for some reason, right? Pull it out. Okay, you just take that relay out. It doesn't matter if the module's trying to turn it on. The power on the load side is not going to reach its destination. There are some vehicles where the ECM will not communicate it at that point. And a couple examples I can give are older Toyotas and older BMWs. I've seen this on both of them. And I've seen other vehicles that are no comms when this circuit is disabled as well. Those are the two that come to mind. But I've seen many vehicles where that is not the case. Chryslers, GM, Fords, this relay can be taken completely out and you can still talk to the modules. Now, is the engine going to start? Is all the functions going to work? Maybe not, but I'm talking strictly communication with a module. When you pull that relay out, you can still talk to a lot of modules. So communication is not dependent on this circuit getting power in some cases, but in some cases it is. How do we know? And I don't have a cheat sheet of all the vehicles. I just gave you two examples that I can reference. That doesn't mean it's all. And even saying GM vehicles don't need that relay, I could be wrong on a particular model. I'm sure there's an example out there where that's incorrect on a GM vehicle. But how do we know when we go into testing, right? What do we do when we get to that point? You see the relay that is powered up by the module that then feeds the same module. It's like a chicken and the egg situation. But how do we know if that power is needed on that circuit for that module to communicate? Here's what I do in those cases, right? I'm going through my checks, powers, grounds, whatever. I find there's no power on there. Okay, is it a dead module? Is it a problem with the circuit? I will just do the job of the relay and then verify that power is actually getting to that circuit, at the module. That's important too, because you could have an open wire, blown fuse, or something like that. But I'll do the job of the relay. Right, and that might be my first check is, okay, I don't have control from the engine control module, so the relay's not on. Okay, just jump the relay. Now do I have power here? Okay, can I communicate with it? Nope. Okay, that circuit doesn't matter. That's how I do that. Now, if I do that and then the engine control module communicates, okay, I got to figure out why that relay is not on. And I just had that on a BMW X5 recently, where once I did the job of the relay, the DME came on, started talking, and I had to find the reason why that relay was not working. The control wire was open in that case. So the DME was trying to turn it on, but it couldn't, right, because the control wire is open. And even though it's received the ignition on and it's attempting to turn this relay on, but it's not getting power on the load side of that circuit, it's not going to talk on the scan tool. Can't talk to it, no comm. So again, My trick there to eliminate the question mark of whether it matters or not is put power onto that circuit and then see if your situation changes. That's it. It's real simple, and then you don't have to wonder whether you need to chase that or not. Because if applying power there does not change my communication situation, I don't care that relay is not being activated. That's my simple trick to get over that, so I wanted to point that out here. Okay, so let's say we've gone through all this. We verify our scan tool is correct. We don't have some gateway issue. We've got proper connection to the network. We've got our wake up signal. We've got our, serial data wake up signal, if there is one. Everything seems to be present. Is there anything else that could cause a module to not communicate? And there is. There's plenty of different options. Could be a failed module, obviously. Could be the wrong module, which I guess could be failed, but we've run into situations like that where it's just the wrong one. You could have a 5-volt reference that's pulled to ground. You could have something overloading the module. We had that recently with the fuel pump control module on BMW, where the fuel pump was overloading the control module to the point where it wouldn't communicate. And I think those were things were actually failing before we got to them. The shop had put in a couple and burned up both of them. But anyways, there's other things that could cause a module to not talk and not necessarily be the fault of the module, right? And the 5-volt reference being a big one, right? You could put another module in there and it's not going to fix it. You're still going to be a no-com in that situation. So how do we get past that last piece of variables that may change car to car to car? Now, okay, you can check all your 5-volt references. You can do that. One of my favorite things to do here in this case, it doesn't work always. There's some caveats, and I'll talk about that, but it's something that I will do often, is remove the module from the vehicle and connect to it on the bench. Now, I say this like it's really simple to do, and I realize that it is not always really simple to do, but I have a lot of bench equipment, and I connect to a lot of modules on the bench for cloning. I've gotten used to finding pinouts, finding the pins on the module, and connecting up a bench harness. And you can get one of these from Isaac Rodell, a little bench harness. It's got all these pinouts. It's got some switches on it. And it's got an OBD2 connector. And man, it is slick. I have 3 or 4 of them. Carry one in my van. I got one at the shop. You just go boom, 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 powers, grounds, communication. Okay, let's go. And you can talk to the module on the bench. Now, there are some limitations to this, right? How about that gateway module, right? Is it even possible for my scan tool to directly talk to this module? There are some situations where it might not, but a lot of modules you can, right? Through CAN lines, if you connect up, you can talk to the module with the scan tool on the bench. So where I'm going with this is if you connect up to it on a bench, connect your powers, your grounds, your ignition, wake up, and you can talk to it on the bench, but not in the car, well, you know the problem is on the car side, and you better take another look at, did I miss a power or a ground, or is there a 5-volt reference that's shorted to ground? Is there an output that's overloading this thing, causing it to not communicate? What did I miss in the car? And that's just kind of a final, if I'm real questioning the module, I feel like I'm missing something, is test it on the bench. See if you can talk to it on the bench. And a few different things here, just tips on bench testing modules that I've noticed over the years doing this. Find a way that you can measure the amperage of the module when you are turning it on. So the power supply that I have has voltage that I can adjust, which I like, but it also shows me the amperage that's being drawn by what I have connected. Now, bear in mind, you're probably going to have some power going to your VCI, depending on how you have this set up. So there's a little bit of amperage there, but you can figure out what is the amperage draw of my VCI, and then you can subtract it from the total. But a lot of modules are going to be somewhere in the neighborhood of 300 milliamps to 1 amp when they are turned on. And that can definitely vary depending on the control module. There's certain ones that might pull a little bit more, but usually they're going to be somewhere in that range when they are fully awake. So you can look to see, like, okay, I've connected up all my powers and grounds and I've turned on my power supply. what is the amperage draw? If it's 0 and you verify that you connected everything correctly, well, there is a good chance that module is completely dead. It should not be 0. It should be up towards that 300 milliamp at the very least. So you can look at that. The other thing that you can do is scope the communication lines that go into that module. Now, this will vary depending on the style of network that it's connected to, but with a CAN style, and this I should mention too, depending on where the terminating resistors are, there might not be one in the module you're testing. Just add a 120 resistor onto that bench harness as well, and it kind of completes the network, or at least gives it some resistance, so it's not just a completely open network. But once you've done that, you can scope it, and you can actually see activity, the module talking on the network or trying to talk to other modules when you first turn it on. And where I found this to be useful is modules that require a wake-up signal over the bus to turn on and function. I've run into this a couple like body style modules where I'm trying to talk to them on the bench. I flip the communication on, and if you catch it real quick with the scan tool, maybe you can get in with communication, but sometimes that's tough. But you can see it on the scope, and you can see, okay, hey, this thing's trying to talk at least. And then that might influence me to go back to the car and double check things, right? So that's kind of where I'm going to leave this one. Hopefully some of that is useful. And the next time you run into a control module that you can't talk to, you can use some of these tips and tricks to help you get through. If you got any others that you'd like to add in here, or maybe add something to what I've said, point something out that you don't think's right, please let me know. There's an email in the show notes that you can shoot stuff over to, or you can go on the Facebook group, which you can also find in the show notes. But that's where I'm going to leave this one for today. Thank you so much for listening. I really appreciate it. With that out of the way, though, let's get out there, start fixing the world one car at a time.